All right, so now I'm going to talk about section 6.4. This is a super fun section. It's on solving trig equations. So what's really important to keep in mind is, again, this is where the knowledge of common angles, your sine, cosine, tangent is crucial. And number two, all of your techniques from algebra are crucial for solving equations. Factoring, when you have the product of two things equal to zero, one is zero or the other is zero, all of those things are huge in this section. So as I say with every other section here, I encourage you to read through the book, read through the examples. These are the general steps that you're going to use in order to solve trig equations. Isolating your trig function is huge. And then how you go about solving it really depends upon what it looks like. Okay, so what I plan to do is work through a bunch of different examples similar to what you're going to see so that you have an idea as to how to approach each of these. Okay. They're going to be a varying level of difficulties, but my hope is to show you how to do them and why to solve them in the way that we do. Okay, so let's start out with a quote unquote simpler looking trig equation. I say quote unquote because nothing is simple when you're learning it. Things are only simple once you've learned it and see it. So please be patient with yourself first and foremost. Suppose we want to solve the sine of x is root 3/2. Okay. Well, in the back of my head, I know that this is a common angle going on here. We know that the sine of pi/3 is root 3/2. Okay, but that's not the only angle where my sine is equal to root 3/2. Recall that my sine is positive in my first and my second quadrants. So not only do I have a first quadrant solution of pi/3, but I also have a second quadrant solution where my reference angle is pi/3. What will this angle be? Well, pi minus my reference angle pi/3 is 2 pi/3. So notice here, going once around our unit circle, we have two values that give us root 3/2. Okay, the thing is, these are periodic functions. So if all they ask is for solutions from 0 to 2 pi, these are my two solutions. However, if we want all solutions, then we want to think about all coterminal angles. And we know that we have a period of 2 pi. So for example, if I let k equal 0, that means we're just going once around the circle. If k equals 1, it means we're going to pi/3 and then we're going around one more time. If k is equal to 2, it means we're making 2 full circles and then going to pi/3. Okay, so what if, on the other hand, I want to solve this one? What if I want us to find all solutions of, how about I have 2 times the cosine of theta is negative root 2/2. Okay, well, whenever we're solving, again, we want to isolate our trig function. Okay, so what we're going to do is say, well, we got this 2 that we're multiplying by, we can divide both sides by that, and I'm going to get the cosine of theta is negative root 2/2. Now, before I find all solutions taking into account the period, what I'm going to do is just find my solutions from 0 to 2 pi. So notice I have my cosine being negative. So I have to ask myself, in what quadrants are my cosine negative? My cosine's negative in my second quadrant and my third quadrant. Now, I know that pi over 4 is going to be my reference angle because I know that the cosine of pi over 4 is root 2 over 2. So to find my second quadrant angle, I'm going to take pi over 4 to be my reference angle, and I claim I get a value of 3 pi over 4. In my third quadrant, pi over 4 is also going to be my reference angle, but instead of taking pi minus the pi over 4, we're going to take pi plus another pi over 4 to get 5 pi over 4. So again, if all I was doing was looking for solutions going one time around my unit circle, one solution would be 3 pi over 4, and the other solution would be 5 pi over 4. If we want to show all solutions, we could say that's plus 2k pi. All right. How about this one? What if I want to find all solutions where the sine of theta is equal to 1? Well, again, this is one of our common angles in the back of my head. I know that whenever I have the sine and cosine with 1 or negative 1 or 0, I'm on my unit circle. And I know that my theta is pi over 2. So if my only solution was from 0 to 2 pi, this is it. If I want to show all solutions, I've got to consider going multiple times around my circle. Okay. Another one from our unit circle. What about the cosine of theta? Oops, cosine of theta is theta. No, cosine of theta is 0. Again, whenever our sine and cosine are 0, 1, or negative 1, we're on our unit circle. The cosines are x value, and I know that pi over 2 is one solution, and 3 pi over 2 is the other solution. And again, I can then keep adding plus 2k pi. All right, so those are some starts. Let's now get to things that look a little bit funkier, okay? What if, for example, I wanted us to solve 2 times the sine of 3 theta equals 1? Notice it's a lot more involved in here. And this is where that step 2 of those steps that I had written down on my previous page, as well as provided in your book, where we use the if needed, make a substitution for the inside. Okay. Well, first off, isolate your trig function. From here, we can certainly say that the sine of 3 theta is 1/2. This is one of our really common angles. But this 3 theta is really messing with me. So what I'm going to do is I'm going to let u be equal to 3 theta. I claim then I'm wanting to solve the sine of u equals 1/2. We can totally do that, okay? Our sine is positive in our first and second quadrant. So in my first quadrant, I know that the sine of pi over 6 is equal to 1/2. In my second quadrant, pi over 6 becomes my reference angle, and pi, or 6 pi over 6 minus 1 pi over 6 is 5 pi over 6. So those are my 2 solutions within just one revolution, okay? But I found my value of u. That's not what I was originally wanting. I was originally wanting to find this theta. Well, u is the same as 3 theta. So if u is equal to 5 pi over 6, and pi over 6. That's the same thing as saying 3 theta is equal to this guy. And 3 theta is equal to that guy. Now, in order to solve for theta, well, we divide everybody by 3 or multiply both sides by 1/3. So I claim that my solution, well, pi over 6 times 1/3 is pi over 18 plus, well, this is essentially 2 pi over 3k. And here I get 5 pi over 18 plus 2 pi over 3k. So notice my way of solving is very much the same. I just did a little substitution. And you can certainly check your answers by plugging the values in. Let's do another one like this. Okay. Suppose now I want to solve the cosine pi over 4 theta is equal to -1. We want to know theta. Okay, notice my trig function is already isolated. So what I'm going to do, since I don't just have a theta, I have a number in front, I'm going to make a substitution again. I'm going to let u be the same as pi over 4 theta. So I'm wanting to know, where is the cosine of u equal to -1? Again, whenever you have the sine or cosine being 0, 1, or -1, we know we're on our unit circle. I know that u is equal to pi. I know that the cosine of pi is -1. And we could say, if we want to take all solutions, then we have to consider all coterminal angles. Okay. But again, if our question originally asked us to solve for theta, we need to write our answer in terms of theta. So if u is equal to this, that means pi over 4 theta is equal to that. And we can certainly solve for theta by multiplying both sides by 4 over pi. Well, pi times 4 over pi is 4, and 2k pi times 4 over pi is plus 8k. All righty. So we're actually not going to get into the factoring solving trig equations until the next chapter. I realized that after I said something here. But let's do some now where we're going to use a calculator. Okay. When you have the 1/2 √3 over 2, √2 over 2, 0, 1, and -1, those are our common angles. But for the next couple, let's find our solutions just on the interval from 0 to 2 pi. And how about for this one? We want to solve, does not really matter, the sine of x equals -0.58. All right, well, notice if I want to find my values of x, I'm going to have more than one solution here because my sign is negative in 2 of my quadrants. My sign is negative in my 3rd quadrant and in my 4th quadrant. Okay. So whatever we do starting out first, we're going to then need to convert into each of the particular quadrants. Now, at this time, notice we're in radian mode. So be sure that whatever calculator or computer program you're using, you move it to radian mode. Okay. So before we can find our third and fourth quadrant angles, what we need to do is find our first quadrant angle. Okay. So how do we find what value gives us negative 0.58? Well, we can think about taking the inverse sine of both sides. The inverse sine of the sine undo each other. And we can take the inverse sine of negative 0.58. And I get x to be negative 0.6187. Okay. All righty. Now, this is our fourth quadrant solution. If you want to put it in terms of a positive value, we can certainly do that. Okay. But this gives us our reference angle. Our reference angle is 0.6187. And remember, this is in radians. Okay, so I know that in my first quadrant, theta is 0.6187. And again, I'm in radians. So how would I find my third quadrant angle? Well, that's my reference angle right here. So what I'm going to do is take pi plus 0.6187. So literally, I plug pi in my calculator plus 0.6187. So one of my solutions is 3.7603. And my fourth quadrant solution, I could look at as negative 0.6187. But if I want to think about it as this is my reference angle, I could take 2 times pi minus this 0.6187, and I'm going to get 5.6645. It's a little funkier when you have to use a calculator, okay? But remember, you're finding your reference angle, and then you find the angle in each of those quadrants. All right, well, let's do one where we have to put a couple of these things together. And we will be getting more intense with our trig equations as we learn more. But I think that this is sufficient for now. So we're going to put a calculator solution in with a substitution solution. So what if I want us to find two solutions of this? 7 times the sine of 6x is equal to 2. Again, we're going to isolate our trig function. That's our first step with all of these guys. And because I don't just have a theta or an x, I'm going to do my substitution again. I'm going to let u be equal to 6x. So really now at this point, I'm wanting to find where is my sine of u equal to 2/7. Well, in order to find u, we need to undo our sine, which means we're going to take the inverse sine of both sides because the inverse sine and the sine undo each other. And we're wanting to find where our inverse sine, what our inverse sine of 2/7 is. We don't know this one offhand. So again, I'm going to make sure I'm in radian mode, and I'm going to find the inverse sine of 2/7. Literally, I'm just plugging that into my calculator. And going about 5 decimal places, I get u to be 0.28975. All right, now going back, what I want to say is as follows. This is my first quadrant solution. Notice I'm wanting my sign to be a positive value. So what other quadrant will I be in? Well, my sign is positive in my first and my second quadrant. So this then becomes my reference angle in my second quadrant. So in order to find the angle, I'm going to take pi minus 0.28975. And you get about 2.8518. Okay, so we found our first quadrant value of u and our second quadrant value of u. But we wanted x. So we say that u, or 6x, is 0.28975. Or u, or 6/8, is 2.8518. Well, we can certainly solve both of these sides for x. And what we do is we divide both sides by 6. And so one of my solutions is 0.04829. And if I take 2.81, sorry. I just noticed something. So pi minus 0.28975. Yes, 8518. So if I take this value and then divide that by 6, I'm going to get 0.4753. So notice this put both of those together. It took our substitution, and it also took us using our calculator. All right, well, this should certainly get you going in section 6.4. Thank you.